Hi, I am Dr. T.N. Kavitha. Today we are going to see some problems based on binomial theorem. Here the first problem. Use the binomial theorem to find the seventh power of 11. Already in our previous lecture, lecture 1, we have completed the binomial theorem. Using this binomial theorem, 1 plus x the power n equal to x power n, nc1, x power n minus 1, like that we have expanded. So using the binomial theorem expansion, here 7th power of 11, 11 power 7 is written like this in the form of binomial theorem. So 10 plus 1 the power 7, it expanded like this, 10 power 7, 7c1, 10 power 6 plus 7c2, 10 power 5 plus etc. up to the 7c7. It is only possible up to 7c7, since the next term will vanish. Here the 10 power 0 becomes 1. So the next line, on simplifying this, the 7c1, 7c2, 7c3, on simplifying this and get the product, finally we get the answer. So the second problem, show that 2 power 2n minus 3n minus 1 is divisible by 9. That we need to prove. Okay, divisible by 9 we need to prove. So the integral, all positive integral values of n. So let us take the 2 power 2n as 2 square the power n minus 3n minus 1. So that becomes 4 power n minus 3n minus 1. So again we take the binomial expansion for 4 power n like the previous problem. So the 4 can be written like this, 3 plus 1 the power n minus 3n minus 1. So let us take the binomial expansion for 3 plus 1 the power n. So that becomes like this, and finally we have two terms, minus 3n minus 1. Add those terms. On simplifying, we get the series like this. 32, that is 9 is a factor in each term. So 22n minus 3n minus 1 is exactly divisible by 9. Okay, so the prove that, next problem, prove that if a positive integer, the integral part of 4 plus square root of 10 the power n is an odd number. So its expansion, we need to find the positive integer. Its integral part is an odd number, we need to prove. So first let us take that integer plus factor. So let us take this term as integer plus factor. So integer I, factor f. So proper fraction it is. F is a proper fraction and I is an integer. Consider the expansion. Root 10 lies between 3 and 4, that we know, because the square root of 10 values are 3 point something, right? Therefore the 4 plus root 10 is a fraction when n is a positive integer, and let it be alpha. So now 4 plus root 10 the power n plus 4 minus root 10 the power n we need to take. Take the expansion of both and simplify. Finally we get the expansion of the right contains only even powers of 10, and since the binomial coefficient are all integers, we get the expression within the brackets is an integer. So hence we get the result. We need to prove it is an odd integer, right? So we need to prove it is an odd integer. So integer plus a fraction plus alpha equal to 2 into an integer. 2 into an integer. So 2 into integer gives the even number. So therefore the fraction plus alpha equal to an even integer minus 1 minus I an integer. So f and alpha are the proper fractions, therefore f plus alpha becomes less than 2, hence f plus alpha is equal to 1. Less than 2 means it is nearly to 1 or 1. Okay, so integer plus 1 equal to an even integer, because every odd integer plus 1 is an even integer, therefore the I should be an odd integer only. 1 plus I plus 1 is an even, so okay, when you remove the 1 it is an odd integer, so I becomes an odd integer, so the integer is an odd term, odd integer, that we need to prove. We proved now. So the next we are going to see the next problem is in our next lecture. We are going to see the next problem. So see you the module in the module 1. The lecture 2 was completed within this few problems. Okay, see you bye in the next lecture.